right, so now we're looking at notes about subgroups. This is syllabus topic 411. Proof of subgroup tests are the proofs that you need to know for this one. And then they talk about it in your syllabus over here as well. So right now we're going to start by defining what a subgroup is, trivial subgroups, and proper subgroups. And we're going to look at the symmetry group for an equilateral triangle to help explain subgroups. So you might remember for an equilateral triangle, then we're thinking about, that's our dihedral 3 group. And remember there was, for an equilateral triangle, we had 3 different rotations that made symmetry. And we also had 3 different reflections. So we could think of our Cayley table for those. So we have our rotations, the rotation where we didn't rotate at all, and then 120 degrees and 240. And then our 3 reflections. So repeat those. And then of course, we've got our filled in table. So if we don't rotate at all, then we still have the position of not rotating at all. This acts as an identity of not rotating at all. So we would have each of those. Identity going down as well. If you reflect over yourself, of course you're back to looking like not rotating at all. So we have those down here. Okay. And then we can think about all of our other rotations. If we rotate 120 degrees twice, we get the 240 rotation. And then if we rotate 120 and 240, we've rotated 360 back to our original. So we have all these from our previous notes, so I'm just going to go and fill them in. And then R1, R2. Okay. All right, so here's our Cayley table. Notice within our Cayley table, if we look at this area here, notice within here we have our Latin square properties. We have something that's closed. There's an identity element. There are inverse elements for each other element. So within our group, we have a subgroup. Yeah? So it's just what it sounds like. Subgroup is a subset of a group that is also a group itself. So we could say, we could define H as being just this portion. I'm going to fill it in. Okay, I filled in H. So we can say that H is a subgroup of D3. Every group has two trivial subgroups. The first trivial subgroup is just the identity. So we could write a group that's just R0. This, of course, is a little bit ridiculous, but it meets all of our definitions for being a group. So we call this one a trivial subgroup, which is just the identity. The other trivial subgroup is the group itself. So there's always 2 trivial subgroups. Any other non-trivial subgroup is a proper subgroup. So this one is trivial, as is this one, because of course the group itself is a subgroup. So within this, we have one proper subgroup. There's also another proper subgroup within here, and I'll leave that to you to try and figure out what it is.